Okay, guys, good evening once again. So we are back for another session. So we're going to be continuing with the trigonometric ratio. Yesterday we had looked at the sine ratio. Today we'll be looking at the cosine ratio. All right. Now, in a similar way to how we have been identifying the sides that are relating to the angle, is the same way that we are going to continue with the cosine ratio as well as the tangent ratio. So we're just going to look through, go through the examples, and then move on to the tangent ratio. And then if we have enough time, we can look at some questions. All right. So can anybody remind me can somebody state the cosine ratio for me? What does the ratio state? Should I ask someone, or will somebody volunteer?
Can you repeat, sir?
Can you state what the cosine ratio is for me, Ms. Wesa?
Adjacent over hypotenuse.
Okay, so the cosine ratio is adjacent over hypotenuse. All right, so with that said, these examples are going to relate the adjacent and the hypotenuse side to the angle given. All right, so here we have a triangle. And so we are given the angle C. We are given the side CA, which is 120 millimeters. And then now we are asked to find the side BC. All right. So as I mentioned before, whichever side that we are asked to find, it is customary to label that side with an unknown. And in this case, we're going to label that side with X. All right, guys. Now, before I go through the process of solving this question, I would like any of you in the class to make an attempt to solve this question. Can somebody walk me through how they would go about solving this question? Any volunteer, or should I ask someone? I realize people don't like to volunteer, so it's probably easier to ask someone. Miss Green, would you like to walk us through how to solve this question?
Sir, I'm not at home at the moment. I'm on the road.
What about you, Mr. Lamar? Would you like to solve this question?
Sir?
Yes, Mr. Lamar, go ahead.
Yes, sir.
All right, so walk me through the process.
Sir, can I get one minute? I'm going for the calculator.
All right, you can have a minute. In the meantime, guys, just look at the question and see if you could figure out how to solve it. All right, so you're trying to find the side BC. You're given the angle at C, and you are given the side AC or CA if you want to read it from either end. All right, so just waiting on Mr. Lamar to find the calculator.
Sir?
All right, go ahead now, Mr. Lamar, if you have your calculator. Just tell me what I should do first and walk me through the process.
Sir, you find the cosine ratio. So,
all right.
Cosine ratio is adjacent over hypotenuse.
All right, so we need to write down the cosine ratio. So in shortened form, we'll write cos for cosine Cos, we are finding cos of the angle C. So in terms of the sides, which sides would go over which side?
Sir, X would go over 120.
All right, give me in terms of the letters first at the vertices.
All right, sir. So
The side
CB,
X.
CB, CB.
All right, CB, or if you want to say BC, whichever way. All right, so let us go with BC since we're kind of keeping alphabetical order. So, all right, BC
Over AC.
So BC over AC. All right. All right, what next?
So then you're going to put in the real values.
All right, so let's substitute for whatever values that we know. So we know the angle C would be 38, so we're going to put in that angle.
Cosine 38 degrees, yes, sir.
Cosine of 38 degrees. And just bear with me with this device, students. Writing with this with the mouse is not the most comfortable thing. All right, so it's cosine 38. And that would be degrees. And that would be equal to which side over which side now, Mr. Lamar?
So X over 120.
X over
120.
All right, so we're now trying to find X. So before we even do any calculation, we can make X a subject, that is keeping X by itself on one side.
Yes, sir.
So what we do next? Not hearing him, Mr. Lamar.
Yes, sir. That I probably forget, but
okay, so
on the left hand side,
what we want to do, Mr. Lamar, is have the X by itself. So
yes, sir.
On the right hand side, we realize that it's being divided by 120. So that 120, we want to get it to the other side. But we have to look at what the 120 is doing to the X. And so whatever it is doing to the X on the right-hand side, we use it to do the opposite on the other side. So on the right-hand side there, the X is being divided by 120.
On the left-hand side, we're going to multiply it.
Right. So we are now going to use the 120 on the left-hand side. So we would have 120 times cos of 38 is equal to X. So this is where now we'll have to use our calculator to find what the cos of 38 is. So what do you get? Oftentimes you can round your answer off to 3 decimal places if you have a bunch of decimals. Now, if you can work your calculator without rounding it off, you would get a more accurate answer if you calculate with all the decimals that you have.
Okay, sir.
And then you round off your answer based on the place values that there are in the question. So,
yes, sir.
So what is it that you get for cos 38? You can work it with the full decimals that you have, but for my purpose, I need 3 decimal places.
Okay, sir. So 0 point.
So we have 0.788.
788.
And ensure that you round it off correctly. All right.
Yes, sir.
All right. So now that we have rounded that off, we can now multiply the 120 by 0.788, and that would give you x. So x would give you what? X would be equal to
the nearest whole number is 95.
All right, so to the nearest whole number, it would be 95. And so we can now put in our units, which is the unit of measurement that is being used in the question, and that would be millimeters. So it is 9 millimeters. All right. Anybody else agree with this procedure? Raise your hand for me, please. All right, good, Miss Wilson. Anybody else? Miss Green? Good. Mr. Adams? Guys, remember your participation is welcome, and that's a way of giving me some feedback on whether or not you're understanding. All right, guys, so if you're good with this question, I'm going to clear what we have now and move on to the next example. Is that clear to everyone? All right, so from the question, we would find the cos of 38, which is BC over AC. Then cos of 38 would be BC over 120. Put in the value, BC is equal to 120 cos 38, which is times, we're multiplying. So that would give you 94.6 if we are rounding it off to 1 decimal place. But if we are rounding it off with the same unit of our same places as they are used in the question, we would round it off to whole number, which is 95 millimeters. All right, guys. Now here we have another question, another example. So I'm going to ask that, and just allow me to correct this slide, students. Well, all right, I guess give me a second. Let me just stop sharing for a little. All right, guys, that seemed to be. All right, so here we are now. So would you like to attempt this question and see what result you'll get for the answer? And then we can go through it afterwards. I'll give you about 3 minutes to attempt this question. Anybody wrote the question as yet? All right, let's say somebody want to walk us through the solution.
Sure, sir, I'll try.
All right, go ahead.
So the cost ratio, which is adjacent over hypotenuse, sir, and we're finding the side AC.
All right, so we write down the ratio. So we're writing the cos of which angle?
AC, sir. The side AC.
Not the side, the angle. Which angle?
Go again, sir. Oh, angle A.
All right, so the cos of angle A.
Yes, sir.
And that is equal to?
60 degrees.
No, what's a ratio?
Adjacent over hypotenuse.
All right, give me in terms of the letters.
AB over AC.
AB
over AC.
Over AC. All right, next what we'll do.
All right, sir. So we would replace with the numbers. So cos would be cos 60 degrees equal to
60 degrees.
Equal to 28 over x.
Equal to 28
over x.
All right.
All right, sir. So we want x to be the subject.
All right. So what will we do to get x to subject?
So we would, all right, the side that x is on, sir, we would divide it with 28 and then multiply 28 with the other side that the cos is on. So 28 would cancel 28 on that side, leaving x to be the subject.
All right. So the problem with that, Ms. Wilson, is that in order to make x the subject, it cannot be in the denominator. So first you have to remove it from the denominator, because on the right-hand side, you notice that x is in the denominator. So
yes, sir.
Even though you would want to get rid of the 28, first have to get the x from the denominator. So in this case, it is the x that you now have to move to the other side, right?
Yes, sir.
So the x is dividing the 28, so moving it to the other side, what would happen?
Multiply.
All right, so on the left-hand side, you would have x now, x times the cos of 60. Or if you want to write that's just x cos 60, that is So it's x times cos 60 is now equal to 28.
Okay. Okay, sir.
All right. So now that you have this equation, now you can now make x the subject because it is no longer in the denominator.
Mm-hmm.
All right. But now mean that you have to get the cos 60 now on the other side.
So that would mean we have to take away, sir?
No, not take away. Look at what the cos is doing to the x in
Oh,
terms.
yeah, it's multiplying, right?
It's multiplying on the left, but when you move to the other side, it has to do the opposite.
So we would divide over the other side.
Right, so x now would be equal to 28 divided by cos 60. Guys, I hope everybody is following. All right, so now if you divide now, before you divide, you need to work out what the cos of 60 is. Supposed to be
0.5.
So now you would have 28 divided by 0.5. So you will get x to be equal to what?
56.
All right, exactly 56?
Yes, sir. That's what I'm saying.
All right, so we use the unit in the answer, so we're working with centimeters. So it's 56 centimeters. All right, is that clear to everyone? Raise your hand if you are understanding, guys.
Sorry, leave.
All right, so I guess we can move on to another example. All right, so going through the question once again. So we see we have cos 60 equal to the side AB over AC. And then we know that AC is 28, so we have AC over AC. We have cos 60 equal to 28 over AC. Now to make AC the subject, we'll have to bring it on the left-hand side, multiply, and then we bring down the cos 60 on the right-hand side and multiply. So if you're paying close attention, you see that that can be done in one step. So we want to make AC the subject, which is what we use as x in the previous workout. So in order to make AC the subject, it is in the denominator. We want to get it in the numerator, so to speak, or on the other side, so that we can make it a subject. So on the other side, if we bring this AC across and times it by cos 60, then we'll get it on the other side. But in the same time, we could just bring down the cos 60 at the same time. So in other words, it's like an exchange. We bring up the AC and we bring down the cos 60. And so that will give you a one step instead of two steps. So we would now have AC equal to 28 over cos 60. Then we work out cos 60 to be 0.5. So we have 28 over 0.5 equal to 56 centimeters. All right, guys. So everybody should be clear on that. So moving on. All right, here we have another example for this exercise. Now, this is our diagram. Now, you're asked in this question to find the angle theta. So I'm just going to give you just a little time to find where theta is. All right, let me see if I can fix this. That's my second, guys. Let me fix this because everything is jumbled up with these. All right, here we are again, guys. Just see now whether or not you are able to determine the angle theta. So the angle theta is right here. All right, so I give you about 3 minutes to try and do this. When you finish, guys, just raise your hand so that I can see who is finished. Anybody arrive at an answer as yet? Would you like us to go through it together, guys, or you want a little bit more time to work it out? All right, I guess you want to work it out, so I'll give you a little bit more time. Everybody now ready to work out this question for us? Let's weigh some.
No, sir.
Mr. Lamar, Ms. Green, Ms. Cavero, all right. In the interest of time, because the Zoom going to shut down shortly, so I'm just going to walk you through this one. All right. So the first thing that we want to do, guys, is to we clearly can see that this is an isosceles triangle because you have two sides which are equal and you have the base, which is the unequal side. So once it's an isosceles, it's already drawn, there's a line perpendicular from the apex to the base already. So that means we can cut the isosceles in two right angle triangles. And so if we just take the left half of the right angle triangle, the left half right angle triangle and work with it, then now we'll be able to use this to find what the angle is. So somebody can walk me through the process. Ms. Waysome, would you like to walk me through the process from this point now?
So I'll try. I have that already, sir. Yes, I did divide into 30 centimeters and get the 15. Then I have the cosine, which is the adjacent over hypotenuse, sir. So,
right. So
50
we write
over 50.
The cosine of x, or in this case, it would be theta. The cosine of theta is equal to which side of it?
Adjacent over hypotenuse, sir. So that would be 15 over 50.
Drop the letter.
I'll say BD
So
over AB.
BD over AB.
AB.